What is autophagy and how does it work?
Yeah, so autophagy is actually a Greek word and it means self-eating. And so basically, the way it works in our body is we have this amazing innate intelligence that God put within us that is constantly coordinating all of our processes in our body to give us the greatest possible survival advantage. And so when when our nutrient levels go down, our body needs a continual supply of either glucose or fatty acids for energy, right? And so if we're not eating, if we're, in a time of famine, all of our ancestors went through periods of feasting and famine. So if we went through a period of famine, our body would start to break down stored sugar. We call that glycogen in our muscles and our liver, and stored fat, right? So we have that stored body fat, and it would use that for energy. But another thing the body needs is amino acids. And so it needs amino acids to produce white blood cells, to produce albumin, and all these different carrying proteins, sex hormone binding globulin, right? Thyroid hormone, right? All these different compounds that have protein backbones inside of our system, or our proteins. We hear about things like C-reactive protein and things like that. So these are proteins in the body, and we need to create those. And so if we don't have a supply of amino acids coming in our body, the innate intelligence will start to break down proteins that are not functioning well, right? And this is the amazing thing about the body is it knows where the inferior cells, right? And inferior cellular organelles within all of our cells, we have organs within the cells, like the mitochondria, Golgi apparatus, endoplasmic reticulum. And these all have to do with cellular function. The mitochondria are the most well-known. And when we think about mitochondria, we think about cellular energy production. They also have a sensory component as well, where they help to adapt their energy production to the needs of the environment, and environmental stressors and toxins and things like that can actually cause them to go into more of a hypometabolic state as well. And so going back to this idea of autophagy, the body needs to constantly create new mitochondria. It needs to constantly create new proteins. And so it will go in and find areas where proteins are dysfunctional, right? So if we have dysfunctional proteins, they're not functioning the way that they should. A large buildup of dysfunctional proteins will actually cause chronic disease development. And so when we have this period of famine, and one of the ways the body knows we're in a period of famine is this hormone insulin goes down. So when we're constantly consuming food, we are increasing our insulin levels, particularly if we're eating carbohydrate-rich foods. We're going to have higher and higher amounts of insulin. When insulin drops down past a certain threshold, so when it gets low enough, it triggers our body to start to burn fat. And then also we can start to go into this state of autophagy, break down these proteins and create new amino acids. And those new amino acids, again, we'll take those and we'll start to actually repair different cellular structures. Like, for example, the mitochondria will start to create new mitochondria. And all of us have a lot of damaged mitochondria within our cells. Just the process of oxidative stress and the process of creating energy creates a rusting process, or we call that oxidative stress, inside the cells. And particularly the mitochondria really get affected by this. And if we don't turn those mitochondria over, they become very dysfunctional and they become metabolically inflexible. Normally, the mitochondria should be able to burn fat for fuel and also burn sugar. And when they become dysfunctional, they can no longer burn fat effectively for fuel, and they become obligate glucose metabolizers, meaning that they basically are just stuck in this kind of sugar burning mode. We call that glycolysis, and they sputter out a whole lot of free radicals and just a little bit of cellular energy. And so we start to break down these mitochondria, and we call these, when mitochondria become dysfunctional, we call them senescent mitochondria, or older aged mitochondria. We start to break those down, and we take the raw materials and we turn that into new, healthy, stress-resilient mitochondria. And ultimately, the quality of our life is going to come down to, mitochondria are so important that the quality of our life really comes down to the amount of stress-resilient, healthy functioning mitochondria that we have inside the cells of our body. And so if we have a buildup of senescent mitochondria, we're going to have really poor function. We're going to have poor cellular function, poor organ function, poor overall function. If we can get rid of those and turn those into new, young, stress-resilient mitochondria, then we're going to have significantly elevated overall physiology and overall function.